All right, thank you so much, Paul. Thank you everyone for attending this evening. Like Paul said, my name is Dylan Henry. I am one of the assistant directors of graduate admissions for the Schar School of Policy and Government. If you have any questions about the Schar School, the application process, or pretty much anything in the between, feel free to ask any of us, and we'd be more than happy to chat and discuss further. But the real portion of the event tonight is led by Todd Laporte on the screen. So Todd Laporte is an associate professor here at the Schar School, and he teaches courses on climate change adaptation policy, global political economy, critical infrastructures, global internet, public policy, technology, instructional change, institutional change. And he received his PhD in political science back in 1989 from Yale University and his BA in sociology and political science in 1980 from Swarthmore. And with that, if you have any questions, please feel free to utilize the Q&A section or feel free to raise your hand and we will get to your questions not only throughout the presentation, but at the end as well. And with that, take it away.
Well, hello everyone. Thank you for joining us here tonight. This sampler course, it's a real pleasure to be here to talk with you all about this issue. It's my main research area and teaching area, the climate issue. And in this political time, it's also, I think, of the utmost importance topically and in terms of the policy environment that we're likely to be confronting for the foreseeable future. This course is one of several climate classes that I've been teaching since about 2007 or 8 or so. One of the things about the Schar School is that because we have a policy focus, at least in a significant portion of the school, we're often sort of exploring and excavating policy issues and then going much deeper and looking at the deeper roots of those policy issues. And for me, this has been a research endeavor and a teaching enterprise that goes way back in different to different parts of my own upbringing and my own education and my own teaching and work at the university. Let me just say a couple of words about how I came to this that may help to situate all of this. I was at the first Earth Day when I was in middle school, I think it was in the early 1970s, and have long had an interest in the environmental situation, the crisis, as well as energy issues. I'm originally from California, the San Francisco Bay Area. And I absorbed a lot of the sort of techno and science and policy and countercultural sorts of swirling currents that produced a kind of center of a lot of ferment and activity and intellectual work that was done around the issues of environment and energy. But I took a departure from that material until the climate crisis began to kind of mount, and it became apparent that we were on a collision course with scientific realities that many of us were reluctant to accept. And so I began to think about the problem of, well, how are we as a society going to deal with the coming climate crisis? It wasn't, to me, in the early teens, a question of could we stop the climate change from happening? But more a question of how would we manage, and particularly how would the most vulnerable among us manage to deal with the simultaneous challenges of temperature changes and extreme weather, wildfires, as we all have seen in the latest weeks and months in California, where my parents are locked down right now, not just from COVID, but because there are evacuation orders that are potentially going to be delivered to their house. My parents are in their mid-late 80s, and I'm quite distressed about the situation simply because they're threatened and I can't do anything about it. So this is real for me. I studied, as Paul or Dylan mentioned, I studied political science at Yale, and I left there to become a policy analyst when I graduated from my doctoral program. to be a policy analyst on Capitol Hill, working in the now defunct Office of Technology Assessment. It was a congressional research agency that worked on medium-term policy issues for the US Congress, committees of the US Congress. I worked there for 6 years, learned a lot about the policy process, not as an academic, but as a participant, briefing senators and their staff and House members, and in interacting with agency operatives, senior officials in different departments, and working closely with the policy community and the science policy community. It was a real education. I think of it as a kind of postdoc experience for me. And it was formative in my perspective, I think, in looking at policy issues through the lens of both an academic background, but also from the background or the perspective of what's doable here. What is something that we can, how can we craft policy and how can we navigate the politics in order to achieve our public purposes? So I came to Mason from that experience and have been in that vein ever since. And this course, I think, reflects the culmination of the different strands of my own background. I'm absolutely delighted to teach this course. I love it. I teach several different courses, as was mentioned, but this is really one of my most fervent passions. So I'd like to walk you through a little bit of what it is that we do in my classes. I'm not a stand at the front of the room and have a sheaf of notes in my hand kind of lecturer. I'm really more of a discussion leader. And the courses that I teach are highly interactive. As you may have seen from the syllabus, there's a lot of reading that we do, and students post their thoughts and comments about the readings on Blackboard. It's an electronic course system. Many of you may be familiar with such courses. And both to make sure that students actually do the reading, which it's essential that in my classes that people do the reading, because I'm not going to tell you what the readings say, but it's also a way of students to commit to each other, to work together, to master the material, and to do so in a way that's quite social. My courses are ones where they form strong relationships with one another, often that last through their time in the program and beyond. And I'm proud of that commitment to the collective and collaborative aspects of learning. This course, it takes up the question of climate change, less about energy technologies by themselves, but more about the wide range of aspects of the climate challenges. And I want to open with a quote here from John Holdren, who was the President Obama's science advisor, who argued with respect to climate change that we have three choices: mitigation, that is to say, reducing greenhouse gas emissions; adaptation, that is to say, how do we deal with the changes that are coming; and suffering. I like the way that he puts this, not because I like suffering, but because I think it really does squarely frame the challenges that we face. Either we can figure out how to make the problem less problematic, or we can deal with the problem as it is. And we have to recognize our humility, that we have less control over the outcomes than we might think, and that suffering is a consequence. In other words, this is a real thing, real people are on the front lines, and that we need to take the impact on the public and people seriously at the outset. Holdren continues, we're going to do some of each. The question is what the mix is going to be. The more mitigation we do, the less adaptation will be required, and the less suffering there'll be. Holdren is a kind of hero of mine, I think, in this field. And I take a lot of inspiration from his work in the Obama administration, as that administration tried to prepare the United States and to participate in world affairs in such a way as to slow the progress of global warming and to dampen or lessen its effects. So the course looks at both aspects, reducing greenhouse gas emissions as well as adaptation. The course, what I'm going to go through over the next 45 minutes or so, I aim to finish up around 7:30. I'm happy to stick around afterwards if people would like to have other questions. But I don't want to use up all of your evening. All of us are busy lives. But I wanted to just walk you through a little bit of how this class is set up. I often will ask students to watch videos or podcasts that are germane to the subject. I'm not a faculty member, and many of the colleagues I think are similar in this respect, that we're not orthodox in the sense of this is all about academics all of the time. So popular treatments of subjects can open conversations and can connect with students who may feel they may not have been in the classroom for a long time, our master's students, and who may be a little bit leery about, well, what's this experience going to be, but also to connect at a cultural level, at a popular sort of treatment. How issues are discussed matters a lot to how they're framed and to how we can talk about them. So good communication and understanding issues, where people are and where they come from, is really important to me. So listing, a short rap video, a speech by the climate activist Greta Turnburg, and films that topical. We don't watch them in class because that's a waste of our class time together, but I do ask students to read, to watch video materials beforehand. Of course, the internet is full of this sort of material, but we also have this third item here. The Bill McKibben in the Fight Over Climate Change is referencing a service the university's library has that makes available materials that are rather difficult to find in the open internet available to students. And so being a part of the university community opens that avenue up for you. I just finished introducing my current crop of students to the university librarian, our designated liaison librarian. I think university's resources are just stellar, astonishing, and the library staff is terrific. And they offer a great deal of help to students in navigating research activities and subjects, even specific topics. And I think it's a real strength of the university to offer those kind of services to students. The second item here, subscribing to professional newsletters, is a reminder to me to tell you that part of the education at the master's level in particular is about becoming a qualified professional. And as much as I loved my undergraduate liberal arts experience, I recognize that where many students are here because they have a career interest that they'd like to pursue. So to get students then up to the standard of what professional discourse is about, professional topics are about, then I always ask students to subscribe to the kind of industry newsletters or specialized press that helps people become aware of what the issues are from the perspective of people in the profession. As a former policy analyst myself, I understand that world pretty well. This is what I would do if I were entering into a field that was a little unfamiliar to me, where I had some methodological or sort of some claim to being a professional, but didn't know a new area very well. And that's, I think, a hallmark of professional work in our time, is that we're looking at an ever-changing and rapidly changing, in fact, rapidly accelerating rate of change in what it is we have to know and how we find out about it. So all of my students I think of as being researchers, not just PhD students, but we all need to be aware of what it is that's going on and keep up with it. There's no fixed body of knowledge that we just have to master and then we're done learning anything. I think it's a process of continual learning and education. So subscribing to these kinds of newsletters like this one here, Inside Climate News, which won a Pulitzer Prize a couple of years ago. So this is high quality stuff. Daily Climate is a product of an environmental health research group, and they're a kind of an aggregator of materials. Both of them are aggregators of materials from elsewhere, as well as producing content on their own. Also, when I do a course, I will also say, point to the materials that newbies, real novices, might want to tune into before we even get started. I don't assume that anybody knows anything about the subject before they get to our class, but you know, the learning is fast, the pace is brisk, and the reading is demanding, even though it isn't hard reading. It's really, there's a lot of it often, which is par for the course. If you work on Capitol Hill, you need to be up to date without necessarily spending a lot of typical sort of set aside time. You have to absorb things as you go. Often that means depending on friends and colleagues to help you keep up to date and you help them keep up to date. So things like short videos of this particular one here, Global Weirding with Katharine Hayhoe. Katharine Hayhoe is an evangelical Christian who is also a notable climate scientist. And she's produced some terrific communications vehicles, short videos that she did for PBS that is assigned, so you can sort of feel a kind of gentle and gradual kind of entry into the subject matter. Just a side note, this is a painting, a pastel drawing, actually. It looks like a photograph by a notable climate artist. I like to make sure that students understand that this isn't just about the reading. It's not just about the issue, but the cultural background that is an alternative way of grasping material and finding a way to have a kind of emotional connection to it. So art is often a way to do that. Unconventional ways of communicating about science and policy. So get to the original, to the class itself. So I want to start out with this illustration here. We need to know in this course about enough about the science or technology in order to understand what the implications of what science is telling us in this case. This is I think, probably the most comprehensive, and I'll show you in a few minutes another version of something like this. This really kind of identifies the problem that we face. I'm going to draw your attention to the blue line here. The blue line measures the difference of departure from the norm of the last 800,000 years of global temperature averages in the world. And you can see it goes up and down depending on a number of factors. There is a kind of geophysical variation in the way that climate functions. It's a complicated one. It has to do with the way plant life, and mostly plant life, has evolved and then decayed. It is a response to atmospheric conditions that are due to things like meteor and asteroid strikes in the Earth. But this periodicity here, this rough periodicity here on temperature, also gives us is connected to the axis on the right-hand side here, which is carbon dioxide concentrations in parts per million. That's the typical way of measuring how much carbon dioxide there is in the atmosphere. And you can see that the two go hand in hand, that as carbon dioxide levels go up, temperature levels go up. And as carbon dioxide levels go down, as when the oceans, for example, absorb a lot of carbon dioxide, then those levels may go down. And you can see this very close kind of concordance of the two data series, concentration of carbon dioxide and temperature. And so the notable thing here is to look at this, of course, this vertical line here. This vertical line represents about 150 or 200 years of atmospheric concentrations of CO2. Given the way in which these lines, the blue and the red line, track one another in the historic past, one has to ask, why is this line so much higher than any other period in the Earth's history for the last nearly 1 million years? And why is it doubled to, in this case, over 400 parts per million from the global historic average of about 250 or so? That's, of course, the question of the era, and it has to do with human activity, industrial activity, the burning of fossil fuels that create a huge influx of carbon dioxide and other greenhouse gases into the atmosphere. And one wonders, well, how long is it going to take for this temperature level to match or to rise commensurate with the carbon dioxide concentration? It's a scary thought. If carbon dioxide levels, if temperature levels go up in a historic, as the historic record suggests that they will, then we'll be living in a world that is considerably hotter, with considerably less ice, considerably higher sea level, and considerably changed zones of temperate zones where human beings can thrive, considerably reduced zones of that comfort zone or temperate zone. And then when you think about it, in a world with over 7 billion people, with a reduced size of the area that they can live comfortably in, that there's going to be an increase in conflict over resources, over the adequate provision of materials. Things will be crowded, and conflict is likely to emerge. And as Holdren was warning us before, a great deal of suffering. So this is a really big deal then that we pay a lot of attention to this line right here and worry a lot about, well, what should we do to address that challenge? So in the first few sessions of this class, I assign a number of general introductory readings that would sort of help students to grasp what the import here is. As you know, climate change has been a politicized and politically fraught issue for a couple or 3 decades. And it's one that has endured a political onslaught of misinformation and disinformation. But even without the disinformation, it also has it poses such significant challenges to the way people live and the kinds of lives that they lead, the way in which we run our economy, that the investments and the commitments that human beings, and I'm not just talking about the United States here, but I'm talking about everyone, those commitments are so strong that the idea that we are facing a radically different future is very hard to get one's head around. I understand that. That's one of the important challenges here is how can we effect changes in such ways that are not themselves so destabilizing that they engender the kind of resistance that would, in fact, that we're seeing now, of a refusal to accept that this is happening, let alone to do something about it. So how to communicate that. Bill McKibben's piece, which I ask you to take a look at, Global Warming's Terrifying New Math. This is a piece that was published 8 years ago. But it lays out, in I think one of the more compelling ways, some of the challenges that we face. He mentions 3 numbers, which are changing. I'll update you a little bit on what those changes are. 3 numbers, a 2°C limit to what we can sustain as a planet on a planetary average basis before bad things begin to happen. That actually has been downgrade or down scaled to 1.5 degrees. And it's probably should be even lower than that, that the humanity can really only handle 1 degree or 1.5 degrees worth of global warming before irreversible damaging effects really become widespread. the wildfires this year, the storms this year, just in the past 3 months, I think give us a preview of what those changes are likely to be like. Much more common and much more widespread than they are right now. And McKibben's argument about the 2 degrees, which has been updated, as I said, to 1.5 degrees, is a real, it's a journalist's warning about a scientific problem. He also mentions further that one of the second number is the number of gigatons worth of carbon dioxide that we can emit before we get to that point. He reports 565. Current estimates put it at between 280 and 570, depending on how you measure it. The idea of a carbon budget is a simple way of communicating a complicated idea, and it itself is a complicated notion. What counts as in the budget, and how do you account for changes in technology and a variety of other things. But the idea that we have only so much we can emit, only so much pollution we can put into our local pond, so to say, before the local pond begins to really change. The challenge is indicated, the serious challenge is indicated in the amount of time it will take for us to use up our budget. And depending on how you calculate this, we have between 3 and 10 years before we exceed the budget. So there's a serious urgency here, a serious urgency in addressing the problem of greenhouse gas emissions. How we do that, and I'll come back to this when we get to the last part of our discussion tonight. That challenge is even more acute when you consider the third number, which is roughly 2,795 gigatons of fossil reserves, which means that already identified by oil, gas, and coal companies are 5 or 6 times the amount of carbon that the world can sustain. The balance sheets of these companies depend on their assets, which are things like fossil fuel reserves. So we need to ask or require, compel these fossil fuel reserves to not be ever produced. So imagine what the economic implications of that would be if one were to say we have to write off 80% of our assets in order to comply with a global mandate to reduce our emissions to a sustainable level. So you can see how sharply drawn the political challenges are likely to be. The next piece exemplifies another aspect of the work that I do. This is a piece by a journalist from Inside Climate News, Seeing God's Hand in the Deadly Floods, Yet Wondering About Climate Change. I teach an undergraduate class that is called God, Gaia, and Government, which is a class about religion and the politics of climate change. And the idea of a role that religion plays in thinking about how we respond to worldly challenges is a fascinating subject. This particular story is about West Virginia and how a deeply conservative religious community in the state deals with, tries to explain deadly floods and the increase in extreme weather and other events that are related to climate change, and yet struggling with how to reconcile the evidence before their eyes with their commitments to their religious faith, and how religious faith shapes our thinking and shapes our ability to respond is another key issue here, particularly in that class, is a subject that we need to look at. But it represents, I think, a real interest in sympathy for the challenges that all of us face in reconciling ourselves to how the future may be radically different from the past, and what that means, what we may need to give up in how we think about things, even as fundamental to our identity and our communities as our faith commitments. and how those faith commitments may be challenged to deal with the present and future of where the climate may be changing much, much more rapidly than humans can adapt to. The third item here is the How Dare You speech. It was given last year by Greta Turnburg, the young Swedish climate activist who sailed to the UN meetings in September last year. Turnburg I think, has almost single-handedly relaunched or launched a kind of youth-oriented climate advocacy and climate activism that I find fascinating. Of course, students are younger. She's younger than most of our students are, but she represents, I think, the perspective of younger people. I'm in my 60s, so I'm an old guy relative to her and to her cohort. And she is a member of the cohort of many of our students. And so to be clear about the generational challenges here, if you haven't seen her speech, I mean, she's an angry young woman who's daring to raise her voice, and I admire her efforts, and certainly the results have been noticeable across the planet. So by way of introduction, and this is the sort of introduction you might experience in a class of mine, and maybe of many of our colleagues. The second part of this sampler describes sort of, let's get empirical here. What are the impacts? How do we know what's a descriptive sort of account of what climate change is and how it works and what's going to happen. And so I'm going to show a series of screens here that represent some of the data that are very useful for us as we try to understand the policy, as we later try to understand the policy implication, but we have to understand what the effects are. So let me share a different screen with you that helps to pull this onto here we go. All right, so this is not my screen. Oops. Okay, here we go. So, yeah, I got a little bit out of order here. These are the estimates of the carbon budget I just mentioned a few minutes ago. I said between 258 or so and 570. This is the research community has produced a number of estimates, and this is a story from an organization called Carbon Brief that analyzes in detail what a carbon budget is and how it works. And it would be a thing, this article would be quite familiar to students in my class. We'd be exposed to exactly this kind of material. Oh yeah, that's the scene, that's the one we just talked about, the West Virginia story. Oh yeah, okay, and then we got McKibben here. I queued them all up. I should have gone through this more directly. All right, so the story here about what the impacts of climate change are, I want to paint a vivid but responsible painting, a picture of what we could expect. This is a depressing topic in many respects. I think there's also hope at the end of the tunnel here, but I think it can be a harrowing experience to think about what an uninhabitable Earth might look like. There's a discussion about whether or not alarmism or scaring the bejesus out of people is a good idea, or if one wants to maintain a kind of hopeful and optimistic outlook. I think that both of them are required in order to really grapple with the magnitude and the urgency that is needed here. Wallace Wells is a journalist who's published, I think this was in New York Magazine of all places, a very detailed, annotated version of the story about how bad could it get. heat death is one of the top, one of the chapter or the section headings, which if you've skimmed the piece or you've seen the piece, you may recall. He's developing a very careful but vivid picture of what Earth may look like if the current trajectories of greenhouse gas emissions continue unabated. I don't intentionally, well, I do intentionally want to scare people in the sense that I don't want to sugarcoat it. I think students, all of us are owed, I think, the truth. This may be exaggerated in some sense, but I think it's also worth taking it seriously, if only to contemplate, well, how bad is it really? I think this is an important way of commanding the attention of people, if for no other reason than to grapple with the implications as spelled out in pieces like this, and compare them to what it is that the scientific record and other sources would tell us. I don't indulge in discussion about, is the climate changing? Originally, when I began teaching, I began to do that, and I've come to the conclusion that the scientific consensus is so strong, the lines of evidence are so clear from many different kinds of sources, that it's not a useful thing to engage in a conversation about is climate change happening on one hand. On the other hand, I think it's important to accept that it is happening and try to understand the issues from that standpoint. So the way in which we understand is driven, and we're going to get into the science here, originally from here. This is Mauna Loa and Mauna Kea, which are volcanoes on the big island of Hawaii. We can see why this is a useful place to do things with climate measurements. Climate change was essentially, this modern version of climate change was discovered by a researcher who had set up an observatory, a carbon dioxide measuring instrument on the big island at the observatory of Mauna Loa. And you can see why. It is far away from everywhere on the planet. I mean, it is not subject to local pollution conditions, or this is just pure air blowing across thousands of miles of ocean. And it helps us to understand, let me get this to, helps us to understand the data here. This is a NOAA, the National Oceanographic and Atmospheric Administration's collection of the data from that volcano. This is the monthly average of carbon dioxide concentrations in the atmosphere. And you can see the current measurement, the latest measurement is August 2020. We have 412 parts per million. And this is the yearly data track here that shows a pretty unrelenting upward slope since 2016. The right-hand illustration here is the data that go back to the beginning of this data collection in 1957 or 6. And you see it marching on without really any break at all. That's because the phenomenon is increasing. And that vertical line that we saw in the early graph, well, this is the expanded version of that vertical line over a much more finely grained time scale. But let me show you, if we were to look at the full record and how it looks. This is an animation that was done by NOAA that gives the history of greenhouse gas emissions. I'm going to see if I can figure out a way to make this be expanded. Yeah, we'll see here. So notice the date here, 1980, 1970, 1981, and so on. The red dot is Mauna Loa in the Pacific on Hawaii. These other dots are other monitoring stations. And there's a dot here at the South Pole, the blue dot, that shows what the measurements are there. So we're collecting, this is a tremendous collection of data here that we're seeing. Um, as the as time goes on, you can see the line bouncing up and down. That's because of seasonal changes. There's a larger amount of landmass north of the equator, which means that there is more plant life that emits carbon dioxide, emits oxygen or breathes in carbon dioxide. So the Earth's balance shifts over the course of the season as the northern hemisphere goes from winter into spring and spring through fall, when then plant life begins to slow down as plants go dormant for the winter, and the southern hemisphere lights up. So that's what explains the variation here, but we can see, and we can see the monitoring closer to the equator, we can see a higher change than closer to the South Pole, which makes sense because there's more plant matter close to the equator, obviously. So now we're getting closer to we're into the 21st century here. The data are they often vary a little bit from place to place, but the strength of this data collection is that it assembles tremendous amounts of data and puts them in a common frame, a common research enterprise, which the scientific community is engaged in, to develop a clear global understanding of the phenomenon. I'm just going to pause for a quick other second here. You can see the data that we saw earlier, the sawtooth line going up, shows that we are in a continually sort of sawtooth kind of rise as time has gone on. So let's just finish it out here. Get to, I think 2016 is the last year they have for this. Nope, 2000, looks like 2018, pretty close, or just this year then, early. So we're at 411 parts per million. Now what this diagram is doing is it's going back in time rather than forward in time. A different set of data, the original data from the Mauna Loa Observatory, but then we're seeing ice core data that are where bubbles in the ice, they're sampled to show what the concentration is of carbon dioxide. And we're going to be going backwards here. This is 2,000 years before the Common Era, 6,000 years, and we're seeing other ice cores, and you can see the references here. This is all well documented. And on the left side, we can see what the pre-industrial averages are telling us already, about 278 parts per million. In 1979, it was 336. And January of 2019, it was 411. And we can see how consistent the record is. Of course, there's variation. And most of this is from the ice core that was ice cores in Antarctica that the research group headed by Petit and his colleagues put together. This then tells us a historic record that gives us very little doubt about how the climate has been changing over time. So these kind of data are a typical artifact of what we would look at in our class. We need also to think about how these data affect people and what we do about it. I'd like to show you another little diagram here. We think about how human beings fare under different kinds of conditions. And one of the things that we're worried about here is whether or not the activities of humanity are sustainable and whether they produce improved well-being. And this drawing, a diagram here, and I'll show you the animation in a second, shows a combination of the intersection of two major factors. The ecological footprint, that is to say how much of the Earth's resources people use in different places, and the degree to which they've achieved a fuller a human development, this so-called human development index that measures well-being. The higher your human development index number is, the longer on average your population lives, its health status, in other words, the more education it has, and the more economic output the country experiences. It's a very simple measure that captures a really wide range of phenomena that have to do with human well-being. And you can see here that these intersecting lines, this is the line here of sustainability, that anyone below this line is consuming less of the Earth's resources than the Earth will regenerate on its own. So these people are all living a sustainable life, but they're also living a life that isn't very well developed from a human development point of view, right? This is the line of 0.8, which is where it's judged. If you're on the right side of this line, then you have a high standard of living. And you can see the bulk of the world's population, countries, live below this level of sustainability. They're, in other words, living sustainable lives, but they're living lives that are relatively undeveloped in a human development sense. So if we were to accelerate this, and through the lines, you can see a kind of progression here from left to right as countries get richer, right? They are getting closer to being having a high standard of living, but they're also rising slowly above the line of sustainability. Every country follows this pathway. They go, I think this is China, this is India. Both poor countries are rapidly improving. And just to draw our attention to it, let me just, how do I make this thing stop? Here we go. The area that we're really interested in, and the reason this is, I think, such a compelling illustration of this problem, is that this is the area where people have a good life. Their potential as human beings is fully realized, but they're also living lives that are sustainable from an ecological point of view. And the fact that the track is to go along this line, but just miss this sustainability well-being domain, I think is one of the most serious challenges that we face, and why climate change is such an important issue, because it challenges our ability. The ecological footprint is an example of how we consume more resources and produce more carbon dioxide and other environmental challenges in order to live a good life. What we really want to do is to be bringing people into this quadrant here, not skirting it. The more we go up on this level here, the more we're using Earth's resources at a faster rate than they can be replenished through natural processes. And the farther we get away from sustainability, that to me is a really serious, serious problem. And I think it's one of the associated challenges of climate change that we face, why it's important, thinking again about reducing human suffering. All right, let's see. Another way of looking at this problem is to look at the cumulative emissions of carbon dioxide since the middle of, or the beginning of the industrial era. I show this only to illustrate one of the issues that the class deals with, which is who's responsible and who should do something about the problem. And this illustrates that predicament, or that challenge. So this shows that the United Kingdom is the biggest emitter up by the year 1850 of carbon dioxide. They know this by records having to do with how many tons of coal were mined, how much, of course, was burned then, because if it was mined, it was burned, and then how much carbon dioxide it has released. So this is the clear, United Kingdom was the clear leader in the industrial era in 1850. So just watch what happens as the time goes by. 1860, France is beginning to catch up. The United States is sort of up there with France. So it takes, and you can do the horse race thing if you want, to see how the UK has, continues to enjoy a big, big advantage. But the other European powers, industrial powers, begin to catch up, particularly the United States, and then overtakes Great Britain to be the leader in terms of the accumulated emissions that it has emitted. Until the Depression, things began to slow down a little bit. You can see a retreat of the United Kingdom and a few other countries. The Soviet Union begins to take off, and you begin, but we also see a ratified sort of major lead by the United States during this time period. Coming to the current period in the post-Soviet, the collapse of the Soviet Union, we begin to see China and particularly China really beginning to accelerate forward, as is clear from our own experiences with political conflicts with China, that the Chinese are increasing at a far greater rate than anyone else these days. Even though the United States is still, how do I get this to go back? Is still the leader. So historic emissions then play a big role in the politics of who should cut back, who should change, and have fueled the political conflicts about the United States and the Chinese relationship. The Chinese would argue, well, the United States has been the biggest historic emitter, and so it bears a most significant responsibility. And many countries have argued the same. But the United States is saying, well, the Chinese are catching up with us, and they're producing more, and they will produce more in the future. So we need to hold them to account. And therein lies, I think, the major conflict about what the politics of climate negotiations are about. I'm going to stop this screen. Let's see, I need to share a different screen with you and go back to the syllabus screen. So I've listed here in the syllabus the data visualizations, but I also want to show you the climate model that we utilize in class as part of our work. So it's not just looking passively at passive data, but it's also playing with data. And this is a model that's a real model that's useful in gaming what the international negotiations are like about how emissions should be changed, what policies should be put into place that dampen carbon dioxide emissions, and then with a reference to what temperature increases. And I challenge students, and you should try this at home, you have the link in the syllabus, how can you manipulate the emissions profiles, which year they peak, which year reductions begin, how fast the reduction takes place, and then a simple policy choice of preventing deforestation, because trees absorb carbon dioxide, or promoting afforestation, I should say, planting more trees. And I challenge students to figure out, what policy mix here, who do you ask to do what? The United States, the European Union, other developed countries, and the principal developing countries, to achieve a temperature increase by the year 2100 that is underneath 1.5 degrees, which is the target that has been accepted by the scientific community as being the absolute maximum. You can see that we are currently on a path to hit that limit by the year 2030. So we have 10 years to get this line flat. And that's a big, big challenge. Try this at home and see if you can do it and what the implications are. I didn't give you a link to this model, but it is a similar model it's called En-ROADS, which uses a similar kind of modeling environment, but gives you much more control over the kinds of policy options that you might imagine, like a carbon price, for example. We put the carbon price up at the maximum level, then much would change in terms of carbon emissions, but the temperature change doesn't depart that much that we feel like we could declare success. if you wanted to use many more renewables, um, and punish the use of fossil fuels like coal and oil by taxation, for example, with a carbon price, um, increase the use of nuclear power, for example, you still have a difficult time achieving this 1.5-degree target. So this is a sort of model then that can lead to a much better and more contextually sophisticated understanding of what it is that's going on here in terms of how energy and the energy side of climate change could be a part of a policy solution. With all of this in mind, one of the things then that we also need to talk about has to do with the role that in personal behavior, personal lifestyle changes will play in addressing the problem. And so I've asked students to fill out a carbon calculator. There are 3 on the sample syllabus. This is the one from the Cool Climate at Berkeley group, which I like pretty well just because it seems to be quite user-friendly. And you just fill it out and figure out, well, how well are you doing compared to other people like you? And how well are people in your country doing relative to people in other countries? So we do a fair bit of comparative work in contemplating what it is that others do. And the reason for that is because policies matter. We learn from other countries, and we can sort of see what the degree of responsibility is that different countries play. I'm going to show you the Carbon Action Tracker, which is a research group that tracks what it is that countries have pledged to do to reduce their carbon emissions as to achieve their carbon budget targets. This is the EU's commitments, which are, this is the way to read this, is to say this is what the emissions in megatons of carbon dioxide equivalent are, and the green is that they're on track to a sustainable world, and orange or red is that they're not absolutely on track, and the black is that they're just completely out of whack. And the pledges, they've been historically reducing their emissions. They are currently at a, what is the insufficient level of performance. The blue line is the post-COVID policies. So this is very up to date, that suggest they're on a downward slope, even so. But because the requirements to reduce are so stringent and we need to be accelerating our efforts, just because you're improving on a downward slope doesn't mean you're actually achieving an absolutely acceptable result, which means then by the year 2050, they're still insufficient because the emissions are still too high for us to achieve our 1.5-degree target. You can look at all the different countries that are part of this this assessment. The United States is one, which may not surprise you. We are not doing particularly well. Our historical emissions are declining a little bit, but we are haven't committed to policy in any serious way to make a big difference. Developing countries, on the other hand, like Nepal, for example, they're allowed to emit more. And why would that be? Why would they be allowed to emit more carbon dioxide? Well, because they have a very low standard of material well-being, and they didn't play any role at all in making the problem be a problem. So they have, good grief, getting a lot of buzzes from the university's systems. So under these international agreements, the developed countries with large historical emissions are being asked to do their fair share. And the poor countries that have not contributed to the problem, well, they all have the right to be developed as and improve the material well-being of their country. So the negotiations that take place at the international level are quite complicated. And this is, I think, a good overview of that, but the detailed nature of the pledges, gives us the specifics of what they've done and how they do it, what individual countries have pledged, and how that's basically how the system works. This is an aspect of the work that we do. Our colleague Andrew Light was one of the negotiators of the Paris Agreement, and who's much more plugged into this than I am, but nevertheless, he's accessible to students at Mason as a member of our faculty. I mentioned that we were interested in international comparisons, and there are some really interesting cases. This is the case of the German. This exemplifies how much the renewable industry in Germany has soared, and how traditional sources of energy production have stagnated over time because of political commitment that the Germans made to achieve a renewable dominance of renewables. So policy matters. It isn't just a question of technology worldwide just dictates the way we use energy. Policy matters a great deal. And we can learn from the example of other countries to identify those policies and those practices that could make a significant difference. The United States, of course, is a huge player in this game. And it's different than other countries, so we don't want to just import policy from somewhere else. It's not a one-size-fits-all situation here. But we do need to be aware of what it is that other countries do in order for us to take advantage of what the best practices are elsewhere. Now, I don't have any slides for this or screens for this, but we also then are asking, well, what about climate policy, and why are we where we are? And here we have to take aim, and the sample readings suggest, take aim at this problem of climate denial. Climate denialism is a real phenomenon. It's been well documented by researchers, sociologists, environmental sociologists, policy people, to show that the degree of misinformation or disinformation or undermining of the scientific consensus, or at least the public understanding of that scientific consensus, has been a systematic subject of lobbying by the fossil fuel companies, who have largely taken their cue from the tobacco industry's earlier efforts to try to undermine public confidence in science about smoking and its connection to cancer. In fact, some of the same people have been involved, at least in the early days. Politics, of course, matter here as well, and the influence of lobbying and of policy choices. The readings take you through the work that details some of the organization of the climate denial movement. But we also see it in the current administration. Make no bones about it, the Trump administration has not been interested in addressing climate change at all. And in fact has worked systematically to undermine the capacity of the federal government's agencies, Environmental Protection Agency, the National Oceanographic and Atmospheric Administration, the other agencies that deal with both environmental management and environmental science, including Earth orbiting satellite observations and so on. So the reading here by Talia Buford talks about the reshaping of the Environmental Protection Agency. I should mention that I spent a year as a fellow at the EPA in their climate adaptation office at the last days of the Obama administration and the first days of the Trump administration. So I saw firsthand how the process of unwinding an aggressive climate policy took place. So I'm worried as both an academic researcher, but also as close policy observer, that the Trump administration's policies have made it far more difficult for us to achieve the targets that I've shown you, and that the institutional capacity of the climate policy community has been, and the professionals inside of public agencies has been severely compromised. So even if we decided we wanted to make a big difference, quickly we would have to rebuild a great deal of the infrastructure, policy infrastructure for that to happen. And I think that's a real shame. So don't want to shy away from dealing with the political controversies here. And I certainly, and many of the colleagues I think would agree with me on this respect. So let me then conclude with part 4, which looks at the ways ahead. And I titled this section, The Many Ways Ahead, Let 1,000 Flowers Bloom. The urgency is great, the time is short, the magnitude of the problem is significant. So what do we do? What can be done? Well, it's not all doom and gloom. Back in the early 1990s, already we began to have some indication of how existing technologies could solve the problem. A couple of researchers at Princeton University, Pakala and Sokolow, presented this information back in 2004, late 90s. They began to think about it. And what they suggested was that we could look at our historical emissions, we could look at our current path past 2000, whatever the date was they began. And this area under the curve here, this triangle, this orange triangle, was the triangle of how you would have to stabilize from where we are or where we're headed to where we need to be. And they call these wedges, plural, because they think there are a number of possibilities that we already have, the technologies we already have, if only we were to deploy them. And so they've argued that rather than fix a problem that is much further down the road, we should start soon to try to flatten this curve. And we've heard a lot about flattening the curve of the pandemic, and it's the same here. And so these 8 wedges that they identified, each of which is worth a certain amount of carbon reduction, that over the 30 or 50 years, the same global emissions as today could be achieved if we were to deploy each one, or sorry, not each, but all of these wedges, which are different kinds of technologies.
Professor Laporte, I don't mean to interrupt, but you're still sharing the screen of the syllabus.
Oh, God, darn it. Thank you for mentioning. Okay, here it is. Sorry. Thank you for interrupting. Sorry, I'll go back a second here then. Oops, I go back here. Yeah, okay, all right. So this is the historic emissions. And these are the current path. It's this familiar graph. You can see how we, as business as usual, we continue to go up. So the idea of then flattening that curve from where we are now to where we need to be as an interim goal, with the idea that eventually reducing even more, gives us then a kind of a conceptual language to talk about, well, how do we do this? And each of these wedges, as I mentioned, is a technology. We'll just quickly review them in the subsequent slides here to show that we already have technologies and practices that could help if we were to upgrade them or scale them up rapidly over the next decades. This is the under the curve here is the accumulated amount of carbon that is emitted in the 50-year time period, as we saw in earlier data demonstrations. So there are 4 categories: nuclear power, energy efficiency, fossil fuel-based strategies, clean coal, for example, and renewables. And you can see then, here's the bit by bit, showing what it is that we would do today, or begin to do today, that would improve the situation in the future. So doubling the fuel efficiency of cars, or cutting in half the number of miles traveled, using the best practices of energy efficiency in buildings. Could look at switching fuels from natural gas rather than coal-fired power plants, for example. We could capture carbon and put it into the ground. This is a fuel plant a fossil fuel plant where the carbon dioxide is taken out. It's put into a deep salt layer, saline aquifer, where it is sequestered, prevented from coming into the environment. Nuclear electricity is a big issue for many people in this space. And of course, wind and other renewables. So we begin to think about the kind of approaches that we would need, which are, in this case, technological. What I'd like to do is to shift from technological approaches to another set of approaches that I think our students are very interested in. I did a project with them last semester where we looked at, see, is this the screen here? Yeah. Where we looked at what are as a really interesting research project by a group of researchers that are looking for unconventional approaches to climate change. A team of researchers led by Paul Hawken, and this is the news item from Vox, which is listed in the syllabus, where they looked at the scenarios of looking at things like managing Freon, or the cooling gas in refrigeration. Simply by managing that better, we could reduce the amount of greenhouse gas emissions by a tremendous amount. And that's a kind of a technical, these first several are technical in nature. But reducing food waste, I hadn't heard of this as a potential greenhouse gas emission reduction strategy, but it makes a lot of sense. If you have a lot of methane produced by composting food scraps, then if you eliminate that greenhouse gas emission source, then you can make a big dent in the problem. But the one that I really like the most, it's a sort of non-traditional way of thinking about this, is educating girls and women and engaging in family planning. That the number of educated girls translates directly to more energy efficiency, smaller family size, more economic benefits to women, who then are managers of their own economic lives, which means that they engage in more efficiency. I mean, the synergies here are impressive. And I credit Hawken and his drawdown team with introducing a whole new range of synergistic policy thrusts that have as a dual benefit of greenhouse gas reductions as well as welfare improvements. So that not only do climate specialists and scientists and physicists have a role to play here, but people who are interested in agricultural, like food waste reduction, or tropical forest management, or family planning, and or people that are looking at education of girls and women, as I said. Last semester's class that engaged in this project, they did a terrific job of producing policy briefs on these solutions as a kind of, let's elaborate a little bit further on what Hawken and his team have done and try and push it to the next level. I was very proud of the students. They did a terrific job of pulling, of taking these policy innovations or policy domains and pushing them to the next logical step, which have great promise. So the idea here, and this is the full table here of solutions, you can see there are 100 of them or so, from technical to let's see, this is in buildings to the food and agriculture and land use domain to health and education, and so on. There's a lot that can be done. So when I say that we need to think about many, going to share the screen again. Many ways ahead. I'm serious about that, and that's what I find to be so hopeful about the kinds of options that we face. This is not just a technical fix here. This is a whole range of changes that are simultaneously going to need to be happening, that are, but that the avenues are open to many different kinds of people, many different specialties and interests can participate in a climate change project, enterprise. And that, I think, is a real hope. We also look at things like clumsy policymaking and the kinds of policies where there is a, not rather than a silver bullet, but a kind of silver buckshot. There are lots of different ways of participating. Cities are playing a much bigger role, and states, for example, as the federal government is retreating. Foreign examples, as I mentioned, of Germany is a really interesting example as well. So I conclude this sampler with, I hope, on a hopeful note, that there's plenty of scope. The doom and gloom, I think we have to endure it in order to get to a point where we understand the nature of the challenge and take it seriously. And it is a deadly serious challenge. But at the same time, I think there are many avenues for participating in addressing the challenge and in developing professional expertise in working on them. I think this is a domain that students now are going to be the sought after policy professionals, and I don't just mean in in government agencies here, but I mean at all levels in the NGO world, international organizations, public administration, policy, all of it. That adaptation to those changes is going to demand tremendous amounts from communities, that the technical challenges of dealing with mitigation and lowering our greenhouse gas emissions are going to be legion, and that this is a professional career path that, while it's fraught now because of the politics, isn't going away. The public consciousness, I think, is rising on this area, and I think there's nothing but opportunity for people who are well trained to deal as we go ahead. So, Dylan, Paul, I'm going to call this an end to my sort of formal remarks here. But I'd love to answer any questions or deal with any questions. So I think that the drill is that there's a Q&A facility here that is useful for communicating directly here. Let me just get my Q&A window open.
Yeah, we have a question for you all lined up already. So we got a question from Lauren saying, a common complaint that arises whenever I'm speaking with people my age regarding climate change and environmental awareness is the overwhelming amount of emissions coming from industrial and business sources beyond our individual reach. They often feel that the burden of change should often fall on companies, and thus individual lifestyle changes are not important proportionally speaking. So how would you respond to this perspective, and what suggestions do you have?
Well, I think, Lauren, you're exactly right. I think it is the case that individual choices don't matter very much, at least in their magnitude, but that doesn't mean that individual changes aren't important. I think as much for signaling support for alternatives, I think companies do pay attention to what the public thinks and what it does. There is, you may have heard, I think it was in the last week, I think it was a National Association of Gas Producers private meeting. The transcript was leaked, or recording was leaked, that showed that members were quite aware of what the public was concerned about, and that they wanted to distance themselves from the coal industry, and that they are thinking very hard about how to manage public expectations, about the issue of climate change, and that they're worried that younger people are feeling alienated from fossil fuel producers. And so what are they going to do about that? So I think individual choices matter a huge amount. I have my house right here where I am in DC. I've got 14 solar panels on the front, not because I think I'm going to make a big difference to the amount of carbon that is emitted. I frankly don't, but I want to let my neighbors know that I think it's an issue and that we should take advantage of programs that can, if not individually, but can collectively begin to make a difference. After I put my panels up, I don't know, 4 or 5, if you go on Google Earth, I mean, I did this the other day, I looked on Google Earth and found like, 8 neighbors that have solar panels on their house now. Now, did I make that happen? Probably not, but I didn't, I pushed it along a little bit because every little bit helps. And if you begin to feel a part of a larger group, that's where the real bang for the buck is that the collective action that occurs when there's a buzz about an issue, when people begin to mobilize and they begin to march and they begin to vote. Voting is a critical part of the story. It's not the only part of the story. I think there is a cultural change here that needs to happen, that we need to communicate our concern about climate, that the relationship that human beings have to the environment is flawed in ways that make it unsustainable over the long period and even the short period. Now, if we have 10 years, 2030, we have to cut our carbon emissions by 50% in order to make our target. We're likely to miss that. So we need to have a movement that says that's a value that we can collectively demand from our policy leaders and from our business leaders. They maybe feel that they're being dragged kicking and screaming into a new world, but something's going to change one way or another. And all of us are going to suffer, and they are going to suffer too. The Commodity Futures Trading Commission a few weeks ago or months ago issued a report that said that the financial system, the financial structure in the United States may suffer because of the exposure of companies to climate risks, and that their investors don't know it because the companies are keeping the information private. 90% of the companies, I can't remember what the report actually said, but the implication is that the financial system as a whole is being exposed to a systemic risk because of our failure to be clear about what we need to do and to begin to start doing it. And that, I think, is a key consideration here, that there's a movement here. And there's lots of individuals in part of that movement who have their own ways of approaching it, and that there are many ways ahead.
Great, and thank you. And we got a question fairly similar to that, but it's regarding a different age group. So they say the elderly like to use their age as a reason to not care about the climate change because of, quote, "I'll be dead before anything happens." What would your response be to encourage elderly people to act on climate change and when they won't have to face the most severe impacts themselves?
Yeah, I deal with this with my own parents. I hope they haven't tuned into this thing to watch what's going to happen here. Well, maybe they should hear. And they're in their 80s, and I've talked to them about putting solar panels on their house, and it's disruptive. They feel like it would be disruptive, and they feel like they got scarce resources in their elder years, and that for them the outlay to do what we are asking is just too much for them. I think they do care a lot about the future. They care about their grandchildren. They care about their great-grandchildren. My parents are lucky to have great-grandchildren. And it's not that, I think it's not that they, by the time, this begins to be a problem, I'll be dead. I think that's that may capture the concerns of elderly people who feel particularly constrained by their own financial situation. They have to think about themselves first, and they should. But at the same time, I think we need to make, as a matter of policy, we need to make it easy to adopt these big changes. And it often doesn't even require doing anything to your house, for example. Um, it's a matter of public investment in technologies that, I mean, frankly, the biggest changes from the energy point of view are going to be things like offshore wind power, for example, or utility scale solar, not solar panels on your house. That's the most expensive option, but you know, the acres of solar panels erected in farm fields or wind turbines that are erected on farm fields, or solar panels that are on in areas where sun is plentiful, like, you know, Arizona desert. These are kinds of projects that don't require a big lifestyle change, but that could easily be convincing on the basis of cost by themselves. So if, I mean, solar is being, I mean, renewables are approaching parity on an unsubsidized basis with conventional sources now. If you look at the cost curves, there's something called levelized cost of electricity. It's a series of reports that's done by the investment company Lazard Brothers, that shows that as time goes on, those, you know, the cost of renewables goes down as systems scale up and as the technology becomes better understood. So older people don't have to disrupt their lives in order to be beneficiaries. In fact, I think, you know, helping those folks, people like my parents, by helping to come into being standardized ways that are effective of reducing greenhouse gas emissions should be a part of our policy mix. I think we should recognize the vulnerabilities of not just elderly people, but poor people and people who live in marginal situations. I mean, all of them, I think, particularly the poor and the elderly, are likely to be most hard hit by the effects of climate change in terms of health. For example, out west, the fires, because of climate change, or at least partly, are affecting, you know, children with asthma and older people with you know, heart conditions, like my dad. So I think they may be past the point of them being quite active in making advocating for change, but they're so important to develop a relationship with, and to think on behalf of them rather than asking them to do the heavy lifting for us. So it's a great question. Thank you. Anyone else? If anybody has a comment, I'm happy to respond. And Dylan, if you want to turn the audio on for people, if they want to just blurt it out, I'm happy to field the question that way too.
I mean, I have a question myself for you. So
Mhm.
I know from watching TV very recently, I know there's been kind of pushes from companies, large companies such as Amazon, towards building more sustainable mechanisms for how they operate. How do you think that incorporates to kind of a snowballing effect for other companies to follow suit in kind of greener pursuits?
I think it matters, and this is, I think, where the reputational advantages. I think lots of people are looking for ways to, by their own behavior, communicate a message. They endorse, you know, sustainability. They endorse, you know, gender equity, or you know, Black Lives Matter, or whatever. But through the one of the few things that they can do, that aside from voting, which happens episodically and seems kind of remote in terms of its impact, but through their buying behavior and their investment behavior. And companies, I think, in particularly ones that are in consumer markets, are very, I think, are acutely aware of what the sentiment is that's about their activities. So, and I think there is a snowball effect. I mean, your question is really, really astute, because I think the snowball effect is really what is driving, I think, a lot of um, the effort to brand themselves green or greener, even if the commitment isn't a fundamental sort of heartfelt one. You know, it's like, it's a reflex. You begin to get you begin to behave, you start behaving in ways not because you really want to, but because other people are doing it. And after a while, it becomes a way of life. It becomes a normal practice for you because other people are expecting it. So I think that's why this is partly a cultural matter. If we have a culture that is dismissive and doesn't really care, then businesses are taking their cues from the public, and they may be changing their business practices because they have a specific bottom line issue, and they may be exposed to vulnerabilities that climate presents. But it's much easier to do when there's a sort of synergy between the public and consuming public and the voting public and the business community that is out of the norm in terms of compliance with a new standard of renewable energy use or sustainability practices. It certainly can't hurt. I don't think anybody wants to beat up on companies for being polluters. I mean, they're just inheriting a situation from the past where it made sense for them to do stuff with the stuff that they do. It's the deflection to a new trajectory that's really the issue. It's a transition. And companies are going to be rightly arguing, well, you have to make it possible for us to make that transition. Sure, we may have been the guilty parties in the past, but those companies in good faith, who are acting in good faith, can say, look, we're trying to do our best. Help us to do that without punishing us. And that's why I think sensitive policy that understands the urgency and is willing to make big investments rather than just punitive regulatory changes is probably a better mix than just beating up on guilty parties for the sins they're committing now that they committed in the past. So I hope that answers your question. Just my opinion, but I guess I've been looking at this for a fair number of years now, so maybe it's worth a little bit.
Yeah. And if anyone else has questions, please feel free to send them in, or I'm going to just keep asking questions that pique my interest. And I'm just curious from your perspective. I know a lot of kind of policy making is incentivizing or punishing from people from doing certain things. And I'm curious, what do you think has been more effective at increasing kind of a more greener attitude, incentivizing people to make greener choices or making punitive cases against companies, organizations, or people that are specifically being more bad?
Well, this gets into the sort of nitty gritty of how politics works and policy is made. The business community has deeper pockets than many non-business community organizations or interests do. And because they are both revenue producers, they pay taxes, they employ people, there's a strong connection between the private sector's investment capabilities. In fact, they can invest a lot of money, not just to lobby. It's a much smaller amount even than their other investments, but that the public authorities really depend on a business sector that's thriving in order to pay the bills that we all have, that the society has. So I think thinking about the way in which to nudge the business community into a more sustainable posture is by making, I think, big public investments in new technologies, for example, to reduce their costs. Businesses are actually not big innovators, I think. They don't take big risks. It's the federal government is the one that takes the bigger risks, particularly through organizations like DARPA, the Defense Advanced Research Projects Agency, for example. And once the big investments to get, to do some of the first stage sorting of what the innovations could be are made, then the private sector can come along and say, yeah, this is a pretty good bet. If it's too risky, then a business won't invest in it. But if it seems like a reasonable bet, and if the military or the public, NASA, different public agencies have already demonstrated that it might be a good thing, then the business community can get on board. So I think a lot of it has to do with the level of technology policy and the inducements that that come from a steady generous stream of funding for higher risk investments that have a more general societal benefit further down the road. There may be some failures, um, but that's to be expected. I mean, that's true in any investing situation. I don't think the government is, there have been some cases in the United States in the early years of the Obama administration in which investments were big and some payoffs didn't occur. And the administration was criticized for having made bad bets. You know, everybody makes bad bets if they're going to take a risk. Not everything pays off. DARPA, I think, expects only 1 out of every $9 to have a positive return. So I think that's one way. I think it is another way is that being fair about what you require. So I'm personally a big fan of a progressive carbon tax that puts the onus on businesses gradually to improve their operations and limiting their exposure to taxes, and that gives them a stable kind of playing field. You know what the taxes are going to be over the next 10 or 15 years. As long as everybody faces the same tax regime, then your competitive advantage isn't eroded in any particular field, unless you are unable or unwilling to make an investment in improvements. So I think there are, I mean, it looks like it's a regulation or it's a tax, but it's an inducement to change. You can benefit over your competition by making the changes that will save you money and save you taxes, and take you in the direction the society wants ultimately to go. And as I said, I don't really think there's any choice here. I mean, either you pay now and forestall a much higher cost later, or you pay the higher cost later. It's not a question of of asking people to do something that has no end benefit. The whole idea is to smooth it out so that the benefits are continuous over time and not as costly, because it's easier to nudge a super tanker if you put a little pressure on it all the time. You change its course. If you let it go wherever it's going and then try and really do a hard turn, 10 years later, that's a big deal. That's punitive and punishing. So I think the language of punishment and those are the bad guys and so on, I think that it's a real feeling. And I think there are some guilty parties in the fossil fuel industries that have really tried to manipulate the policy environment to their advantage. But I also think there's a growing renewable sector. There are more jobs in renewables than there are in coal. I mean, just think about it. Voting, who are your voters? Who are your workers? They're increasingly in these newer fields. And to manage a transition from a dirty old industry to a new, cleaner one just makes sense from the future's point of view, which is why I think younger people are really keen on this. I mean, this is for them a progressive play. They're not playing defense here. They're looking at the future and saying, where are better jobs that are ones I want in communities that are healthier than the ones I see where older industries are. I mean, if you're a miner, your chances of having black lung by the time you're 50 are pretty high. That's not a job you really want. It's a job that was important, and those people should be respected for their contribution, but it isn't the future. And I think the banks know that, and the investors know that, and the companies themselves know that. It's just a matter of eking out as much value as they can. And when you're in the tail end, how fast do you put it to bed? I think that's the question. So anyway, it's 8:15. It's a little longer than I thought we would be. And I hope if there are any other questions, I'm happy to chat with you. I don't have the ability just at this very second to put my email address up. Dylan, is there a way that people could get in touch with me if they need to?
Yeah, so I'll gladly type in your email address for the group. So it will be in the chat line. But if you have any questions whatsoever, you could also get in contact with myself and the rest of the graduate admissions team at shar@gmu.edu. And I put that in the chat line as well.
Okay,
But
thanks.
you all can reach Todd at T as in Timothy, L as in Larry, A as in Apple, P as in Peter, O as in online, R as in Richard, T as in Timothy, E as in elephant at gmu.edu, or more simply, T, his last name, at gmu.edu.
And I should just point out, Dylan, that on the syllabus, the Staying Alive in the Climate Crisis, my phone number and my, probably not wise to put that on there, but it is. And my email address with the @ symbol is not there, so it doesn't get easily scraped away by somebody who wants to generate a lot of email spam. But you can find it there if you just substitute the @ with an @ symbol.
Yeah.
Okay. Let me just say one final thing, if you don't mind. Is that okay? Dylan? Yeah, I'm just one guy doing this kind of work. David Hart is one of the colleagues, is a specialist in science policy, worked at the White House Office of the Science Advisor for a couple of years in the Obama administration. Andrew Light is a climate negotiator during, of course, also during the Obama administration. The Center for Energy, Science and Policy is a center that SHAR participates in. The Institute for Sustainable Earth is a relatively new venture at the university-wide level that looks at sustainability issues, and climate and resilience. We all are working in different aspects of these issues. We all sort of know each other. I'm a part of just recently submitted a grant proposal to the National Science Foundation about flooding in the Potomac River area and sustainability. How can flood and climate fueled flooding be addressed by local community groups and communities to understand what kind of needs communities have for their own resilience. It's a multi-unit, I think there must be 12 or 15 partners or faculty and employees of the university involved in that grant. We haven't gotten the grant yet. We may not get it, but it's less important that it's certainly important that we get the grant, but what it signifies is that we are committed to doing work collaboratively with each other. We like each other. I mean, we all do different things, but to find ways to work together on problems of public interest, public importance is what we do. And students are often part of those projects. Students they work as research assistants, or they work as researchers. They do projects on their own. They do them with teams. My students do every semester. I teach this climate policy class. There's a project that we do. We brief it to Arlington City Council members, or to the Metropolitan Washington Council of Governments, or that's the sort of thing we do routinely. So if you're interested in doing that, join us. We'd love to have you.
All right. Well, thank you so much for leading this sample class this afternoon and evening. And thank you all so much for joining us this evening. We hope you enjoyed this programming. And if you'd like to learn more about what kind of research areas our professors have and more about our programs, we'd love to chat. You can set up a time to chat with myself, with one of the assistant directors of graduate admissions, and I'd be more than happy to talk to you about our 8 master's programs, our 10 graduate certificates, and even our PhD programs. But with that, I wanted to wish you all a wonderful rest of your evening, and I hope you all have a great rest of your week.